Hey everybody, how's it going? Had a few technical issues, but things seem to be okay now. Just doing a quick audio check before I start. Excuse me. Hey everybody, how's it going? So, like I did at least one or two shows last year, but things seem to be okay. Special now. music tonight and tonight's show, which is why I want to make sure the music or the audio levels are good. Excuse me. My friend Henrik JX3D from Denmark. So, like I did, continually puts out great music last year, and I wanted to special music tonight and tonight's show showcase this. Music or the audio levels are good. Excuse me. My friend Henrik JX3D from Denmark. Are we getting? So, like I did, we're getting multiple. Hold on a second. Last year, and I wanted to. Let me fix something here. Okay, that should be better. Let me use a different routing method here. See if this works. Before I get into it, I'm going to go ahead and show real quick information that you can get his music after listening to the stream, watching it. This is his. Oh, now it's not showing there. Why is that not showing? I tell you, I got nothing but tech problems today. Oh, I know why. There you go. You guys see that okay? So there's the Bandcamp page with the link, and I'm also going ahead and let's make sure it shows up on YouTube okay. Once it flashes, I will turn it off. Hey, I already got a guy swimming through. There's a nice rotifer. Okay, so I'm going to turn that off. I'll put it in the chat. So you can just click the link, but it's also in the video in case for some reason the chat doesn't persist or work or whatever on the replay. There's the chat. Now, I have to make sure that this audio playback works. Trying to stream it through the site here. I have to check the audio levels. Here we go. Seems to be okay, so I'm going to go ahead and mute it so I don't get too many streams and confuse my ears. Excuse me. Okay. Yeah, I put too much water in the slide again, so every time I just barely graze the table, it wiggles. But that's the way it's got to be. Turn this down just a tad. Make sure the mic volume is okay. Okay, I think that will work like that. too low on the stream side. That should be better. I don't want to play with it too much because according to the view meter, it seems to be pretty good. So hopefully it's okay. If you guys do join the chat, let me know if I need to adjust my mic versus that. Okay, let's get on with the shoe. So, you saw a rotor for swimming by. Let's go find him. Ooh, that's weird. My stage is set so much that you can see the you can actually see little versions of the patch stop in there to make the dark field work. That's pretty funny. Okay, that's better. Just have to adjust this now. Okay, that's better. There's this technique called cooler in German. It's actually pronounced cooler, I think. It looks like Kohler illumination, and this scope can kind of barely do it. A scope with a better stage adjust and condenser adjust, and there's a filter insert, but there's also some extra thing with the diaphragm. This has a diaphragm as well as a filter adjust, but there's one more little thing about the Kohler illumination that this can't do that a really nice scope will do. So I get close, but part of it is getting it, like you weren't supposed to see those little crosshairs like that because I had it set wrong. So that was a quick indicator that I needed to adjust it, but normally you would use a much more appropriate method to figure that out instead of just like, oops, that's not supposed to be there. Excuse me. So let's keep looking for stuff. Lots of plant debris. So again, I'm using dark field here. It's actually a mix between dark field and oblique lighting a little bit. It's not totally dark field. There's an interesting little chain of bubbles. Actually, it's funny, the camera showing it darker than my eye is catching it on the I guess I tweaked the white balance a little bit too much, but that's okay. It looks nice on the cameras. Do a quick focus check between camera and eyepiece, and that is off. Let me fix that. It's more like it. No way I can look at one or the other and I know they're both correct. I got the field of view adjusted. Okay, I have some more of these interesting algae surrounded by a gelatinous field. Not really a field, but it looks kind of like a force field. I had these quite a few shows ago. It's that same bird bath I got this from. I love these little guys. I still have to look them up. I keep forgetting. It's a flagellate. And you can see, I'm going to cheat here and zoom in with the software. Make sure, can you see the cursor here? Let me double check. You can, cool. So this guy right here. Good, I'll leave that cursor on so I can point at stuff during the show. cool. I think that will work. Just have to adjust the lighting a bit so you can see more color. See, it's got a reddish cast to it. Adjust this a tad. Now it's more centered. Still needs to be centered a bit. Okay, that's pretty good right there. And let me tweak it so I get it to pop a little bit better. Yeah, I may have to go in one more level. Let me see if I can cheat with the zoom again. That's not bad. Oh, no, I lost it. Too much magnification. Oh, there's a rotifer cruising by. Ew. That's a beautiful rotifer. And he's chasing one of those particles and he can't eat it. It's too big. Damn it, I missed that. Should have zoomed out. Hold on here. Way too zoomed in on this. There's rotifer. He was chasing one of those little algae particles and it's just too big for his little gullet. Get that stupid hand out of there. It's not helping things. There you go. Another crown opens up and it's in full swim mode. Sorry if you get a little seasick here, but I do need to kind of follow it. It's kind of quick. So when it finds something, it senses it, it stops and kind of does this swallow motion almost. Although it's not quite the same as swallowing. Also kind of puts that foot down so that it adheres that foot to the substrate. For pivoting purposes, it's got leverage. And then when it wants to free swim, it lets go and uses its spinning cilia almost like little propellers. But now it's doing an inchworm. So they can do a mixture of movements. They can do inchworm, they can do swimming style. Let me zoom out a tad. It's a little tight. I'm gonna miss some stuff here. There we go. So now it's inchworming. And sometimes I'll follow one for a while. Back to swimming with a full-on corona spinning around there with all those little things. You see he's blowing stuff to the sides. He's sucking things in, but they're missing the... There you go, he just swallowed something there. Go, go, go. That one's too big again. He's trying to go for that big guy. But it's too big. So again, I put too much water on the slide. See this whole margin out there. He's playing outside the cover slip area. And now back to swimming. This is the video game part of the show, where I have to control X, Y, and Z and still try to keep them framed. It's a little tricky. I'm not getting the best frame rate right now either. I'm not sure why. I have to go tweak something on the software. I'm dropping a few frames. Now, a little more contrast when it goes into the area of water outside the cover slip. That damn hand is in the way. Well, this is swimming like crazy. He's going to cover the whole damn slide pretty soon. It's one of the most active ones I've ever found. It's just going and going and going. Usually what they'll do is they'll get lazy. They'll take a break. They'll perch somewhere on a piece of algae or debris and use the leverage of that foot and just create a super vortex with that little crown of cilia, and just let the food come to them, like Vorticella do. They're very sessile. But this one's fun. He's doing a lot of, you're getting a lot of rotifer activities with one individual in just a few minutes here. Inchworm, the contractions, the full extensions, the probing behavior, and then the full on. Let's open up the pipes and go full swim. Now it's getting probably a little tired, so it's inspecting the area better before it goes off and swims all crazy. Some more inchworm action. There's one of those algae again. He's just kind of bouncing around off it. Too big for it to eat. Now it's opening up again, trying to get some stuff coming to it. And remember, these guys are pretty complex for stuff at this magnification, but they are about 1,000 cells. So when you see some other large cilia swimming by, ciliates swimming by, you're like, wow, those are only one cell, and this is 1,000 cells. So it's pretty impressive, the amount of scale. Like your average body cell versus a bacterium. Can be quite a difference, even though he's sucking that stuff in there. There we go. Even though they're individual cells can be widely different sizes. This is 40 power right now. Plus I zoomed in digitally a little bit to cheat, so. Oh, I see somebody in the chat. Hold on, I got windows floating all over the place here. Hey JX3, what's up? It knows what to eat by size rejection. It's chemosensation and size rejection. So if it's too big, as you saw, it was, see this little guy right here? This little guy here. It was trying to gobble one of these up. I zoomed in too much there, but it has this kind of gelatinous matrix around it. It's just a single cell algae in a reddish color. And it bumped into one of these a bunch of times because it's just too big. It won't take it in. But it didn't give up. It kept trying several times until it goes, here it is coming back for it. No, it just gave up on it. By the way, JX3D, is the audio balance okay? It sounded okay when I did a quick check, but I didn't keep listening because it's then I hear myself talk too much and it's too distracting. Whoa, he's going up and down the focus a lot. This is really hard. The Z is probably the hardest part of this. The XY I can figure out, but when they go through too much water, the Z is a lot of focusing. This is good action music for the action sequence. I lost it. There we go. Hands get tired doing this too. It's a lot of micro tweaking of the knobs. he's doing inchworming again, using that foot. Plant and pivot. Not sensing anything, and then planting and pivoting. Now swimming again, that closes up again. It's very interesting. This one's going through all the different behaviors, like I said. Some of them you'll find they just stick to a certain behavior and just kind of hang out. But this one's trying all of its options. See how long they are when they really stretch out. They're very flexible. Very good use of the body's flexibility. And this one I can say body because it is multiple cells. It's not just one cell. But there are some ciliates that can really flex like this, even though it's one cell. You'd swear they have more than one cell because all the stuff they're doing. It's crazy. Oh, level's good, thanks, man. I would engineer it a little bit better, but I wanted to get to the activity, especially since this stuff started showing up. I go, ooh, I gotta track this guy down, because these slides again only last for so long. They start to dry out with the heat of the lamp and normal evaporation. So yeah, right off the bat, I was just looking at those little algae and this guy popped up. This is a good slide right away. Switch back to the other view because these cascading windows are getting tricky. Alright, where'd you go? So you can see it's already got some food in there from the discoloration inside the body. And there's a little dark area about a third of the way down the body from the head area, what I'm calling the head area. And it's dark, so it stands out from the rest of the body there, and you can see it kind of pumping like right there. That's called the mastax, and it's like these little jaw-like structures that kind of it's basically like their version of a mouth, the chewing part of the mouth. They don't have teeth, and unlike a tardigrade that uses stylets to kind of stab things and suck out juices, these guys are taking in whole critters. Although they might be little algae or something like that, they're still taking in whole critters. They need to macerate them. So he's trying to get that gelatinous guy again. Can't do it. Fix the lighting so you can see the outline better. You can see the outline of the critter a little bit better, so you understand why I can't get that close to it. More stuff bouncing off of it. So they're eating a lot of bacteria and really, really small protists, and single cell algae, stuff like that. A lot of the big stuff you're seeing around them is just too big for them to eat, because they have to take in the whole object. They can't just latch on and suck out the juices. They just have to go and get what they can get. So a lot of times you see them reacting to stuff, but you're not seeing what they're actually eating because it's really small. Occasionally you'll see some of the particles swarming around them, like that one right there. The ones that are slightly smaller than that will land and not get rejected. But a lot of times I think a lot of what they're eating you're not really seeing. Stuff is so small. It's great stuff, Henrik. Love this music. It's that foot. It's like a little forked foot. I think it's called a pedicel. I have to look it up again, but similar to if you saw my other videos with Gastrotrix, another multicellular hunter of objects around the area. Looks like those little hunters in the Matrix. Has this hairy body and just kind of snakes around really efficiently. Like it's really almost like it knows where it's going sometimes. And they also have a little tail structure. It's like this foot, and it can adhere and de-adhere from surfaces. This one, I think, in the case of rotifer, I think it's a suction thing. In the case of the Gastrotrix, it's some kind of an adhesive, actually. So they quickly create an adhesive, and then they have a way to release the adhesive, like a counter adhesive or something. I read something about it a long time ago. I have to follow up on that. All these critters are so different. Oh, that's funny. Well, I'm sure like this track fits perfectly for the action here. It's got some tension, it's got some motion, and nice melody and stuff, so I think people will dig it. I know I do. I'd love to go closer on the lobes there with the cilia, but as soon as I do, he's just gonna move and gets out of focus. As you can see, it's hard enough to keep him in frame when he's pivoting all different directions sometimes. Alright, cool. I'm having fun with this guy, but there's so much more to see. So let's go around the rest of the slide. Let's go see what else we got. I got some more of these algae I wanted to look at on here. So this is what we had last time. I caught these off the bird bath. I'm not sure if birds are bringing this in or plant leaves or whatever, but recenter this because it's offset for some reason. And this cluster right here, get a little more light into it. And there's some green, some yellow, and some red algae. I'm assuming these are individual algal cells and not some colony, but they could be small colonies. What's interesting is they're clearly related to the ones that have the gelatinous thing with the flagellum swimming around that the rotifer kept bumping into. But how they're related, I'm not sure. I gotta try to look them up and see if that's some kind of life stage of some kind, or if this is like a resting stage or an early stage, and then they end up free swimming before they reproduce. Hard to say. I'm gonna try my not so favorite objective here and see if I can make sense out of this. So there's some of the green ones. See some structure in there. There's some graininess, little contents in there. And over here, some of the bigger red ones. But it's so heavy red and thick, I have to actually boost to get light to transmit through it. And then, I'm not sure what that is right there. So there's a small green one, another red one, some yellow. So Interesting stuff here. Some more contrast and get some color that way. Alright, let's go back to hunting for other things. Let's hunt for some other things. I'm back to kind of an oblique lighting look, so everything's kind of 3D. Or partially 3D at least. There's a whole bunch of these guys clustered over here with the little spheres around them. See if I can zoom in a tad here. So you can see there's this large colorful section, and then there's this area where these flagella come out, and on some of the video you can see it on either side. There's these paired flagella kind of whipping around to help propel, and this clear gelatinous matrix around them, which is a very interesting structure. I haven't seen this on any other creatures in all my travels with these samples, but I always find this in the bird bath. But I've yet to identify what they are yet. There's a little more oblique lighting to make the 3D pop. Let me zoom in a tad here. Play with the lights a little bit. You can see the structure. Very colorful though, nice little specimens. Now the water is starting to surge in the slide as the air bubble starts to move in and make stuff dry up. So I better hurry up and get through this slide. There's another one down there. Lots of little flagellates bumping around, those little dots wiggling here and there. Very, very small protozoans. More clusters of things. More air bubbles on algal filaments. It's kind of fun. That's pretty much it on the slide, I guess. Just some of those algae and a rotifer. Not bad for the first slide, though. There's one swimming. So if I zoom in a tad and follow it, you'll see the flagella moving here. I'll have to defocus to see them because they're pretty wispy little things. Let's see, they swim in the direction of that line coming out of the top that I was talking about, where the flagellum, actually, I think it's a paired flagella coming out of the top of it. See, it's also tumbling, which is pretty cool. Pretty cool, pretty cool. Hey Matt, how's it going? Enjoy JX3D's music. He's the soundtrack for this evening. I put the link at the top of the chat for his Bandcamp. This specific album. tumbling. Look at that. Very cool. A little more of the outline there when I go contrasty, and you can see the flagellum a little bit there moving. It's really hard to see when you're exposing for color. You miss some of the other details. More dark field, you can really see the kind of the tumbling of the body there, of the cell. Now it's into the area outside the cover slip, which is a different refractive index, so I'm going to skip that. Alright, let's go back to edge of the slide. Okay, pretty much exhausted that slide. Let's make another one. That was from the first sample, from the bird bath. Let's take one from the second sample, which is, that's right, I forgot to mention how I got these samples. This is standing rainwater from the last major several days of rain we had. And if you're into this kind of stuff, look different in UV light? Yeah, definitely. You did have some interesting light artifacts and stuff, and some things actually fluoresce in UV depending on what compounds they have in them. So there's a whole part of microscopy called UV microscopy and fluorescence microscopy. And the really fancy stuff, like the 5,000 and up microscopes, can do that. This one can't, but it can do almost as good as what's called DIC, differential interference contrast microscopy. I'm kind of doing some of the tricks here with the filters and stuff, and some of the oblique lighting tricks, and it's like a hack for DIC, because DIC, like I said, starts around $5,000 and goes up real fast. So one of these days it'd be nice to get a really nice Zeiss microscope that does that. So let me just get this other sample ready. These are settled for a while, so I kind of have to agitate them to get a better mix of guys. But one of the nice things is you can tell right off the bat that these samples have a tint to them, meaning there's already some goodies in the water. It's not just boring, clear water. I already know if I put it under the scope, I'm going to find something here, because there's a nice tint to the water from some kind of suspension. Alright, let's see what's in this one. Back to the edge. Okay, so far nothing special, just some debris. Oh, that guy's cruising. See that? Holy smokes. Zoom out a tad, I'm too close. I'm going to recenter my frame, because this is off center. And I'm going to go look for this guy. He's quick. Flies like those UFOs that keep capturing on the on the Air Force cameras. This is what they were doing. There was actually microscopic footage, and they mistook it for their flight cam footage. Oh, turns on a dime. Look at that. Oh, just like a UFO. Very cool. Where'd it go? There's some really tiny ones there. Let's go find some other ones. Okay, it took off. Oh, there it is again. It's almost too fast for me. Change the lighting a little bit, so maybe help see it a little bit better. I dare not get too close because it'll be impossible to follow. But I like this weird pattern it has. Just almost like a cat. It's like, I'm gonna go over there. Boom! It just takes off. Sometimes after a while when you study them, they do have a pattern they like to follow for whatever reason. Like a search pattern almost. Goes back there and then it goes back over the same area. I'm gonna try, just for the hell of it. Pinching. Let's get a little closer. That's too close. Make sure that's the view I'm supposed to have. Make sure my stream camera's off my stream setting here. There we go. It's almost centered there. See, it's tumbling as it's swimming. This is so good. This is perfect music for this. The kind of creepy unknown critter doing weird behavior to some unusual music. Interesting to see this guy tumbling like that as it swims. Yeah, pretty cool. Alright, let's keep looking. Slides are ticking. Fix my pinch zoom again. I have to realign my... Okay, where's the center again? Gotta find the center. Make sure that's the center of here. Everything's happy. Cool. Let's keep looking. Oh, that's interesting. Look at that colorful fiber there. It has a natural, sorry, not natural, man-made fiber with some kind of a dye. You're not going to see something like that in nature. So there you go. Man-made dyes. More little guys swimming, more little guys. Well, this area wasn't as cool as I thought it would be. I mean, it's interesting, but it's not teeming like the first one was. Let's go back to the first one again. Actually, you know what? Let's mix it up a bit. I haven't done a... you guys want to see? I can bleed from my art and my science. I'm going to make a little quick blood sample here. Because I can. See if we can spot anything other than just red blood cells. Here. It's okay, you want it to be squeamish because you won't actually see the blood. It'll be on the slide as little cells. Got my alcohol so I can clean myself up, and here we go. So there's a technique. Blood smear, it's literally a smear. One I'm going to drop and just do a flat drop and let it smear itself. One I'm actually going to do the actual drag the cover slip across the blood to thin it out a bit. And one's a little darker, thicker than the other one. And since this is limited fluids, this is going to dry up pretty quick, so I better make sure this. We'll do the thin one first. And it's kind of interesting when you put the blood, you'll see these stacking. This kind of coin stacking phenomenon. There's a little erythrocytes. Dark field would be nice or not. It's a little more 3D look, that's kind of cool. Blood cells in 3D. I'm going to zoom way in. So this is 400 power. And you can see them kind of stacking. There's little stacks of coins. There's a certain name for that, I forgot what they call that. But if you look at them, they definitely have a they focus through them, you see you can see they have dimples. This is just blood, no water, no other substance touching it. So they're not going to get too much water and explode, and they're not going to shrivel. Oh, there's a white blood cell, looks like. Possibly. Let's add some better contrast here. So it's not moving, but it looks like some sort of white blood cell there. Hanging out. Usually I'd be hunting around right now, unless it's a dead one. Let me fix my adjustment here. There we go. this off a little bit. That helps me a little bit. If I zoom in. It's not moving, but it looks like it could be a white blood cell. Usually more obvious than that. Let's just cruise around a little bit and see. See how when I focus through, you get that kind of a donut look as it's focusing through different thicknesses because it is a concave affair. Right, let's cruise around and look for something that's not red blood cells. There's one right in the middle. Normally be moving at this point. Just right out of the old body. But it's not doing nothing. See if I can get a little more contrast here. So it's there, but it's not cruising around like an amoeba, like you would expect. That's how they hunt. Let's keep looking. There are a few that got damage, it looks like. When they start taking on water or getting damaged, they have this kind of a sharp star-like blotchy shape to them. But again, I didn't put any water on it at all. It's bled straight out of my finger. They're all stacking up here. So this was the thinner amount that got smashed. Let's go back to the thicker amount that's got the proper blood smear. So there's a whole bunch of it there. Some of it's proper, some of it's just way too smashed on top of each other, so you can really see more color to them. Not seeing any. These are all coagulated, and also the heat of the lamp doesn't help. Okay, not seeing anything. Oh, look at those stacks of coins there. That's wild. Literally bloody stacks of coins. Very, very interesting artwork, actually. If you zoom in, zoom out, you kind of take it all in. See the colors there. It's the color's a little bit false. It's actually a little bit more of a pink. Adjust that more pale here. There's a color adjustment. I can change the. Yeah, that's not right. Maybe it's just too saturated. It's a little bit more of a pale pink like that. A little more on the reddish side than the pink. Oh, looks like the slide was 100% clean. I did get some little fragments of something on there. Because I know I don't have things like that in my blood. Anyway, yeah, the blood's all stacked up in those little coin formations. I have to look up the term again, but blood will often do that on slides. Look at that, all those little stacks. So I'm not seeing anything but erythrocytes for the most part. That's interesting. What's going on there? Do I want to go to oil? Yeah, let's try oil immersion. So I haven't used it for a while. Let's get up close and personal here. Uh-oh. Oil's almost gone out of this thing. Oh, I had a spill the other day and I lost a lot of my oil. Damn it, I have to order some more. Drop in the oil ends. Crank up the light. And let's see what we got here. Particles move around there. I'm not exactly sure what that is. Nope, look at that. All of a sudden it broke loose. There's a gradient. So there's still plenty of fluid here. It looked like they're all dried up, but they're just kind of attracted to each other. So now the blood cells are breaking free, but they still tend to clump. But now you can see them almost like they're flowing through some veins here, or capillaries. They kind of break up and flow through these little sections. That's bizarre. Can't remember the last time I looked at blood cells. In a long time. Ooh, look at that. It's like a worm unfolding. And that's going to separate. Oh, it just separated. That is so cool. Yeah, they're all moving. All the globs are moving. Still attracted. Some little bits come through there. What is that right there? So that looks like one of the white blood cells, actually. One of the smaller ones. That's wild. This is definitely a gradient there. Fluids are on the move. Oh, thanks, Henrik. I'll catch you later. You see my blood cell sculpture here. That's like a screensaver. Next time I'm going to have a, these are clean slides. I cleaned in the sink. So as far as being 100% what's found in my blood, this is not a perfect representation. There's some other weird little particles I'm seeing here that's definitely doesn't look like it came from my blood. So next time I'll make sure I have some brand new slides untouched. Just so I don't have contamination. Because there's some interesting little buggers in here. Little various cells of stuff that, as far as I know, last couple times I looked active blood cells in any amount of time. You can see the erythrocytes, you can see some of the leukocytes, the white blood cells. And you can see, that's kind of it. You don't really see, last I checked you can't really see platelets, but I don't know. Yeah, see this slide is contaminated. There's some little bacteria there dancing around, Brownian motion. I definitely don't have a bunch of bacteria in my blood or I'd be dead. That's what the white blood cells are doing. They're cleaning it up. See if you can see that here better. Little guy's dancing there. Brownian motion. Anyway, it's fun to check it out. Sacrifice some blood for my little show here. It's fun to see him just kind of moving around the fluid and separating and colliding and stretching out. Yeah, it's like a screensaver. Like those little liquid, handheld liquid games used to have, where you would squirt some kind of colored gel or oil, and it would kind of bounce around through little wheels and stuff and come down at the bottom. You push a button, it squirts a jet, and they go flying around. Just all kinds of stuff stuck together. This one's good. Here you go. It's going to slide down this little groove here. Watch this. It's going. It's going. You can do it. It's getting pushed by something. Almost there. It's weird because some of these look like white blood cells, but they're kind of small and they're not doing anything, and they shouldn't be dead. I think that's a white blood cell right there, yeah. See some activity in it. But it's awfully small. It should be much bigger usually than the red blood cells. More stuff tumbling and sliding, oozing down this, whatever this gradient is. Oh, that's cool. You saw the blood cell turn sideways there a little bit. You see how it's like pinched because it's biconcave. There goes another one, biconcave. Down the, oh, look at that. It's like it's flowing through blood vessels. That's pretty cool. Let's go up here where all the action is here. See them tumbling. You can see how they're biconcave. So there's a white blood cell right there. You see that? All the activity inside of it. I can focus through it better. software again. Right there, and you can see all the particles dancing around in it. It's kind of grainy looking. Pardon me. Yeah, it's kind of hard to visualize it, but it's so much stuff on top of other things. More stacks and stacks and stacks. This is my version of a lava lamp here. Blood cell action. I just realized I have a little margin there that shouldn't be. Can I shrink that? If I can make that go off screen more. There we go. That's better. I didn't realize I had that little dumb white margin there. Those little details in OBS. Let's do a little bit more looking at the blood as it's starting to dry up here in the slide. More stacks of coins everywhere. I'll look up that name and I'll put it in the show notes at the end, or in a comment for the stream, because it's a very specific name for the coin stacking phenomenon. Go to the end of the slide and see if there's anything else going on here. Yeah, I can see some of the cells starting to bounce. They're getting Brownian motion here. Whoa, where are you going? It's in a hurry to get somewhere. So crazy. This is also a cheat. So this is an oil immersion objective, making it at standard settings at 1000 power. But then I'm also doing a little bit of a digital zoom cheat with the software, because I was looking at the trying to find those white blood cells, but it's a little over 1000 power. So the red blood cells are pretty small. You saw how big some of the ciliates I've had on streams before, and they're single cell, and you see them very clearly and pretty large at 40 to 100 power. Sorry, 100 to 400 power. And this takes, 1000 power to get any good size out of it. So they're pretty small cells. I think your cheek cells are a little bit bigger. Oh, look at that little duet swimming through the... You get a few single cells, and most of these are kind of stuck together, at least doubles or triples or whatever. That's funny. Wasn't expecting to see this little flow activity. So you get an appreciation for what it looks like inside of a blood cell, without having to go through an elaborate micro camera work. You just put a bunch of blood on a slide, let some of it congeal, and let the free cells swim through it. Just scan through a little bit more. Nice tumbling. Look at that. Very cool. So there are a bunch of chemicals involved in coagulation, which generally explain why these guys are clustering like this, but it could also be some other localized attraction, like you get with chemical attraction at different scales. Not likely at this scale, but there are interesting things that cause 3D structures of macromolecules. Some of them have like 4 orders of structure. You get primary structure as the skeleton of like an organic chemical, like a carbon backbone with nitrogen and hydrogens and oxygen, all that kind of stuff. And then as the molecules interact, they bend and fold based on hydrogen bonding, van der Waals forces, a bunch of other stuff, and so you get this primary turns into secondary structure where you get like an alpha helix or a beta sheet and different kinds of structures like that, and then those can bend further and further to tertiary and quaternary structures, and you get stuff like really bizarre looking structures that make enzymes, and some of them look like some kind of a whacked out 3D model that you made in some clay modeling program on a 3D program. But they're actually based on the individual forces cause them to contort even further to make the final finished molecule, macromolecule. But there's all kinds of like forces that act on stuff at a very small scale, and cells aren't, you know, that much bigger, so they're not immune to some of those, which is why usually it's smaller cells, but the certain amount of size of cells and smaller, like these size and a little bit smaller, and definitely the bacteria really have that Brownian motion stuff from literally heat making water molecules bounce into them over and over again and making them wiggle. So they could be attracted to each other from some kind of chemical attraction stuff, but also there's the most common coagulant in the body. I'm sorry, coagulant is called factor VIII, and people with like hemophilia are basically missing that, or it's not working properly, so they have to take precautions with that, because you can easily bleed out, and not even cutting yourself, just a really bad, when you get a bruise inside your body, you've actually bled internally a little bit. But if you have hemophilia, you can actually practically bleed internally with a bad fall and never really cut your skin. So it's pretty awful stuff. But so then, and of course, there's anticoagulants like heparin, which is most commonly used in blood banks and doctors' offices where they need to have a blood sample stay around for a while in a vial. This is a vial filled with a coating of heparin, so your blood doesn't do this in the vial, all this clumping and coagulating. And I mean, the best one they've ever found is in leeches. Leeches are amazing because they have an antiseptic. It's antiseptic, anticoagulant, and basically a painkiller in there as well. So you don't feel them bite. All of a sudden you get squishy bits in your shoes. I had that in the tropics, where I had my shoes filling with a little bit of blood from the leeches in the wet grass in the rainforest, and didn't feel it. Didn't get an infection from it. Didn't hurt. Didn't and it didn't bleed that much. It bled enough for them to get what they needed, but it's not like oh my god, I'm bleeding out. It's just but if you get enough leeches, obviously it'd be pretty bad. But that's one thing I haven't kept up with the literature, but last I heard, even up to 10 years ago, whatever, they still hadn't been able to pinpoint the structure enough to copy it. Some of these really cool structures we learn from nature and to copy to make pharmaceuticals and treatments and things like that break down at a certain level as you're studying them. Very, very tricky to isolate. And so far, I think it's called Hirundin. Hirundinia is the order of leeches. And I think it's Hirundin is the chemical, the primary chemical. But they still haven't mastered that. I mean, who knows? Maybe they have by now, or getting close with new leaps in technology. But they produced the most amazing anticoagulant, much better than heparin. All right, cool. Let's go look at the edge a little bit, see what's going on the margins. Actually, we'll go the other way, away from the lighter version of the slide. So here's the original area. Oh, that's cool. So you've seen the spiky bits there? So as the cells start to dry out, opposite of what you get is the bulging. As the red blood cells dry out, you get these little spiky structures as you're dehydrating. So when you add like tap water to blood, maybe I'll do that real quick at the end here, or this part of the slide at least. And we'll take a little bit of tap water and add it to the slide. Not going to be perfect. I might even get some specimens in there with this because I don't have enough eyedroppers. First, let me zoom in on this so I don't ruin my chance to get an image of this. A little bit better, closer view. So yeah, as they dehydrate, they get little spikes. As you add water to them, they go from the biconcave structure to swelling, like fatter and fatter and fatter, and they'll pop. Just like you see in other ciliates and stuff on my shows, pop once the contractive vacuole stops working. Alright, I'm going to add a little bit of water to the edge of the slide. We'll see how that works. Probably totally create a big wash. I might just get a big wave of stuff flying across here, so I may have to go to the other end of the slide. And you'll see these guys pop. Put water over here, way on the edge. See, they're getting spiky over here too. The slide was starting to dry out. But I add a bunch of water over here. There's some of the wavefront of the water coming through. I don't see any bulges. Let me try to add to the other side. Let's go back to the side I was on. It was all spiky. So now there's a bunch of movement because the water's coming in. Good old osmosis and general diffusion. See, now it's like, that's really flowing because I added the water to the edge of it. And you should start to see some of these starting to swell up. So a lot of these that were spiky are less spiky now, but they're still not normal. They got some water. should have added some earlier when the cells are all pretty normal. I'm not seeing any pop yet. Oh, look at that guy tumbling. Ooh, you can see the shape. That's cool. Oh, here we go. So I've got a kind of a mass here of stuff that basically looks like these pretty much exploded here. This is a big mush right here. So I think these got affected by the water and basically lysed. That looks like that could be a white blood cell there. In the middle with a little dark spot there. It could be the nucleus of a... But it's pretty small. It's not moving. One thing that's fun about bird blood is birds have nucleated red blood cells, which we don't, which is unusual. But I forgot why that is, but that's one thing that differs. So if you look at bird blood, you'll see nucleated red blood cells. Yeah, nothing's really dramatically popping or making a mush. I guess if it already happened, it was going to happen, so we missed it. But there are some of these look pretty bad, so they've been smushed. So they probably already popped when I added the water. Well, you can actually watch them and slowly blow up like a balloon. Oh, sorry, I missed your other questions. Nikon, no. I wish. I misplaced. I haven't done this since the other day for about maybe 2 months or whatever, and I, as usual, rearranged some stuff, moved some stuff, put some stuff away, and I completely misplaced my adapter I've only had for about 3 months, specifically for my Nikon camera to use the trinocular. So if you look at my older streams from December, November, when I started using them, they're really clear, image quality is much better, colors are better, everything's better. This camera does a pretty good job, and I've done a whole, basically almost 2 years of streams with this camera, and one just before it that was decent from China when I first got my scopes. But the Nikon is the preferred one because not only can I do video, high quality video while I'm also streaming for purposes, you know, I can edit stuff instead of pulling off the stream, but also take high quality stills while I'm streaming, and also use the slow-mo functions and stuff, so I could actually you know, grab a couple seconds of something in slow-mo that's really fast for you guys that's hard to see and play it back live on stream, like I do with my astronomy streams, where I take a time exposure, switch over to the camera view mode for playback, and you can see the stuff coming off the camera. So that's coming up once I find that stupid adapter. Put it away somewhere, who knows. I mean, I obviously didn't throw it out or break it or whatever, but it's just, this is the problem when you have too many things you try to reorganize once in a while and then you misplace it. So I'll find it, but definitely not going to buy it again. It was almost $200, so just for a stupid adapter. So these are all kind of smushed here, so I'm pretty sure these all got lysed for the water that came in. And a lot of the spiky ones aren't quite as spiky as they were, so they got some of the water. Anyway, so that's blood. That's kind of fun. Gotta clean this oil immersion lens now. It's got some gunk all over it. Geez, got a bunch of oil on it. But the nice thing is they clean up very well. Uses nice cleaning tissues. They don't damage anything. Clean it all up and get ready for next time. Very nice. I keep forgetting to do my face contrast retrofit. It's supposedly a 15-minute operation or less to swap out the objectives and the a tweak on the condenser. But I haven't had a chance to do that yet. I've got the kit sitting here next to it. This scope is designed to be reversible like that. So it's definitely on my list of things to do on stream because it would have made the cells look really interesting. Really good at bringing out details of small objects and low contrast objects. It'll make them pop. But then you have to do the whole stream practically with that. I can't switch back and forth, so I'll have to pick a show one time and just do it with whatever I got and cross my fingers that it looks good. Otherwise I'll have to do the best I can to do a stream later with the same samples with the original optics. So what else do I have here? Got some other interesting things here. Bear with me 1 minute. I gotta tweak something here. Okay, I had to tweak something here and see if this will work. I'm gonna swap cameras here. Look at a couple of quick plants here. This is your kind of garden variety ivy. It grows all over the yards everywhere. Mostly introduced from Europe, from what I remember. But this is Hedera helix, and some nice looking leaves. Adjust the contrast here. I'm showing this because I wanted to found something interesting. This is the normal leaf that you find all over the place, but why is that off? Getting some. Ah, there we go. No wonder. Okay, let me fix that. There we go. So your normal everyday ivy leaf. There's the stem, there's the underside. A close look at the venation here. Nice kind of waxy coating there, save moisture. But I noticed this on the one thing that was growing up the wall near my place. It's these little guys, these aerial tendrils that grow to basically latch onto anything. So they act like roots, but they also are very good at growing out and latching onto stuff. So you can see these just coming out of the stem here, anywhere they have to. So here's where a leaf was coming out. There's a leaf further up the stem. And you can see it all along, right by the leaves, they have these little protuberances they grow that are, kind of stiff. But a little bit sticky and translucent. So this is how they kind of adhere to rocks and various types of walls and other trees and stuff as they climb up and basically vine their way up anything. So I never had a chance to look at these before. It's kind of interesting. It caught my eye when I was looking at something else. These little clever buggers climbing on anything. But they're not roots, because roots usually are more opaque and very hairy because they're about absorbing water. These are specific, so I have to go look these up. I don't know what they're called, but they're very specific little structures for latching onto a substrate and continuing to grow the rest of the plant along the vine. But pretty cool. Nice little strategy. Now it makes them really annoying because they climb everywhere, and if you ignore them, they grow like weeds all over your yard, all over your fences, all over your house. So if you like that look, that's fine, but this is the reason they're so successful in doing that. These little tendrils that come out. It's kind of cool. So that's your ivy adaptation. And then I should have picked this closer to the stream, but because the flowers these are pretty succulent in a way, so the flowers are already kind of trash, but this is a dandelion. So some people eat these in their salads, dandelion greens. Little spiny bits on the leaves there. There's the underside. And I had the flower here. I couldn't find a fruiting flower head with the little parachute thingies that take the seed in all directions. This is called a pappus. But here's the flower that I had picked, but I waited too long. It already closed up. It started to dry out. But I can tease it out. Zoom out here. And tease it out. Use my little forceps here to make it easier. pull the... Yeah. I just have to remember how to work in reverse here. Reverse camera angle. But you can see the pedals in there and some massive stamens in there and stuff. So, dandelion. I should have picked it closer so you'd actually have an open flower to look at. And then a couple other things. This is a cypress shrub, similar to the juniper I showed. I'm sorry, the Monterey cypress I showed the other day from Half Moon Bay. This is a more exotic one, but it's got the same kind of scaly leaves. And the lower part's a bit woody looking. Come on, get in there. There we go. I'm all turned around here, hold on. There you go. So the lower part of the stem is where it starts to get more woody, become part of the branch. Still scaly, but more brown and woody. And what else we got here? This is a piece of the asparagus fern you have all over the place. Just your common ornamental. Very spiky. Sometimes you get lucky and find little insects on here, but so far I haven't seen anything. Looks like maybe pieces of insects from shedding. Exoskeletons and stuff. But yeah, it's just little spiky leaves. And from a distance they look kind of almost furry, but they're very stiff. And then one other thing, which is a jade plant. Very shiny, waxy. It's the perfect adaptation of thick, shiny, waxy, very succulent. I'm going to do a break it open here. You can see. How juicy that is there. You can get it to juice, all that moisture in there. Great, see that the cuticle is pretty thick too. The outer skin is quite thick, so they have, you know, the thick, so large volume to surface area ratio. Thick waxy leaves, quite juicy inside, great holding their moisture. Very shiny, reflective, waxy surfaces to make the heat shine away. And they do very, very well. I don't have any more plant specimens. I think that was it. I had one more, I think. Oh yeah, this is rosemary with the little flowers on it. It started to dry out also, but classic seasoning and food. But look at those beautiful little flowers with the long, long pistils on them there. Very colorful. And again, thick, kind of succulent leaves on a small scale. And clustered together. So all these little tactics, and scaly leaves too a little bit. So all these tactics are great for moisture retention. So they grow really well in California, where there's a lot of hot temperatures, sunlight all day, overall dry climate, except for lately when it's raining like crazy. Yeah, they're very, very pretty up close. This color correction on this camera is off. It's more cornflower blue in this image. It's actually, they're more like a lilac purple color in real life. So unfortunately, it's a combination of this fluorescent lighting on this, or sorry, LED lighting on this scope, and the camera balance. So the white balance is not doing so well on this particular scope with because the other light was incandescent, and this being LED, it's not white balance at all. So the green is pretty much right on, but the blue is definitely off. It's supposed to be more purple. Yeah, this is a good album. Henrik did a good job on this one. So I thought it would be perfect for the stream here. So yeah, there's some hairy. You can see the sepals on the flowers. They're also very hairy and waxy. So they're good for also water retention. So yeah, rosemary. And of course it smells great and used in cooking. So nice little shrub. That's kind of all I had for today. The blood was a last minute throw in because I've been wanting to look at blood for a while. I just keep forgetting to do it. So I figured I have this nice, lovely probe, which still has some dandelion on it. And it's just sharp enough to act like a lancet to get a blood sample out of my finger. Of course, I sterilized it before I did it, but I couldn't find any pins or needles anywhere, so I had to use this probe. But it did the job. So anyway, I'm going to call it there, everybody. So thanks for hanging out, Matt. And nice of Henrik to drop in earlier and see this his work showcased in the stream as the soundtrack. I put it in the chat already, but I'll put it here for anyone who jumps in or doesn't catch the beginning of the stream or the chat and later catches it. This is the place to get Henrik's album on Bandcamp. He has a whole bunch of albums. This is his last one he had in December. So, and just as a quick reminder, if you're not watching the stream, here is the visual reminder on the stream. Just do a quick look up top to make sure it shows up okay. Is it there? Is it there? Is it there? There it is. Of course, I highlighted it when I first brought it up, so I had to click it so it would go away. So this is a reminder to go get his music. And with that, I thank everybody again. Stay tuned for more fun stuff. Also, on the MicroAddict front, I did one last night. There was nothing special. The weather was pretty bad, but I wanted to try out some accessories I bought a couple months ago. I haven't had a chance to use yet. One was good, one wasn't so good, and the moon looked pretty cool, but then the weather started to get really bad, so I think it's only like an hour stream, but As soon as the weather gets better consistently, I'll be doing more of those too. So stay tuned for all that, and have a great rest of your week. And I'll see you guys out there. I always say keep looking up and watch the skies for the astronomy one. This one, keep looking closely at things. Enjoy all the small things in life. Enjoy the little spiders and insects and flowers around you, and and also all the microorganisms that do great things for you, like cheese and beer and wine. They're not all bad guys. They're all very interesting in their own way, and also can be tasty. Thanks everybody. I'll see ya.